In this video, I'm going to multiply these two rational expressions together by first canceling out any common factors they may have. At the end, I'm going to identify any x values that make my final expression undefined. But I want my original problem and my final solution to be equivalent expressions, so I'll need to take into consideration every factor, even the ones that get canceled out along the way. So how do I multiply these rational expressions? Well, the first thing I'm going to do is factor all of these polynomials so I can kind of compare their factors and see if any of them will cancel. Okay, so 2x squared minus 5x minus 3 will end up being 2x plus 1 and then x minus 3. And then below that I have a difference of squares, x squared minus 16. So that looks like x plus 4 and x minus 4. Up here I have a quadratic, so it looks like that'll factor as x minus 4 and x minus 4. And finally on the bottom here, one final quadratic. Looks like it'll factor just like this. Okay? So here we are. Let's go ahead and take a look at all the factors to see if I have any common factors that can cancel out. Well, let's start with the 2x plus 1. I have one down here, so I know that I can cancel these 2x plus 1 factors out. The next one's x minus 3, but I don't have any x minus 3's on the bottom. I do have an x plus 3, but they're not the same, so move on. So x minus 4 here, and I see an x minus 4 here. And this final one, x minus 4, will not cancel with this one because that's an x plus 4. Alrighty, so let's go ahead and kind of rewrite what I have here. And I'm going to multiply straight across, but let's go ahead and rewrite it first. And then x plus 4 and x plus 3. Okay. So when I multiply these, essentially you're just going to FOIL them out or do the distribution process here, whatever you call it, or whatever you're comfortable calling it. But whatever you do, you're going to get x squared minus 7x plus 12. And then here you're going to get x squared plus 7x plus 12. Alrighty, I know and I can see that they have a lot of things in common here. They both have x squareds, they both have 12s. They both, in fact, have 7x's. One's negative and one's positive. But you have to be very careful because you cannot just start canceling things out at this point. Just because you see 12s, they don't cancel out. Remember, the only way to cancel expressions is by factoring first and then canceling common factors. But right here we have the factored form and none of them cancel out. So I know that nothing here will cancel out. So the last thing I need to do is to consider all the values that will make this undefined. Well, I can see from this factorization right here down at the bottom that I know x cannot equal negative 4 and x cannot equal negative 3. And that's pretty obvious because those factors are right here and they still exist here as well. Well, what about the factors that were canceled along the way? So my 2x plus 1 was factored and got canceled. So I know that x cannot equal negative 1/2 because of that guy. Because if he is negative 1/2, this ends up being 0, and I cannot divide by 0. That's undefined. The other one was x minus 4, so because of him, I know x cannot equal 4. Okay? But the negative 1/2 and the positive 4 don't show up down here in my final problem, so I need to include them. So I need to say x cannot equal negative 1/2 or 4. And again, the reason I write these down, but I don't write these down, is because these were the ones that got canceled out along the way, and these are still present in my final answer. So what I say now is that this rational expression with this stipulation of x And then my original problem up here, they are equivalent expressions.